Now this video is just going to keep going on with derivatives, but kind of show you more the way you do them and when you're actually studying calculus for the most part. So the first few examples we did on the last video, they gave you a function, say a function like this, and it said find the slope of the function or find the equation of the line tangent to this graph at a certain point. Now that's something you can always do with derivatives. You can find the slope of a curve at a given point using the derivative formula. But what it's used for most and how you'll find derivatives mostly in calculus is you won't find the derivative at just a one specific point. You'll just come up with a derivative function or derivative equation, and then you'll just plug in whatever numbers you want to that equation. Because it's a lot easier to just come up with a derivative function or derivative equation, and then you can just plug in whatever numbers you want and it'll tell you what the slope is. So that's kind of what I'll show you how we'll get to that today. So instead of just finding the slope at one point by doing this whole derivative formula, you'll usually do the derivative formula just with the equation, get a derivative equation, and then you can plug in whatever numbers you want at the end. So I'll kind of show you how that'll work today, and then start to show you one of the main shortcuts that you'll use in calculus to find derivatives. Like finding the derivative of this, we'll do it in a couple minutes later. It'll take us like 2 seconds to find the derivative of this. Once you learn the shortcut, it's pretty easy to use. So again, just to review the derivative formula, it's this one. You don't have to memorize this right now. And when you take calculus, by the end of the year, you probably won't even remember this because you won't use it much because you'll just do all the shortcuts. But first few months, you'll probably have this function memorized because you'll use it quite a bit. But again, there's 3 different ways different teachers show this and different textbooks show this with different letters and different symbols. Some will use like f of a, and some of them will use like this h, and some of them will use delta x instead of h, which means the same thing but just looks a little bit more confusing. So if you see that, it's just the same as this, just going to look a little bit harder at first. So remember, this is basically like the slope formula. This is y2 minus y1, and then when you do x2 minus x1 at the bottom, you just get h, because h is the distance the 2 x points are apart. So it's really just the slope formula, and you're trying to figure out the slope between 2 points as h gets really close to 0, because remember, h is the distance between the 2 points. So again, if you got 2 points on a curve, so you got this curve here, and you're trying to find the slope right here, you wouldn't want to find the slope between this point and say this point to find the slope of the curve right there, because that would be the slope going this way, but you want the slope of the curve right here. So what you would do is you'd slide this point as close to this point as possible, and that's when you make h as close to 0 as possible. And then if you get the slope between those 2 points, you basically get the slope of the curve at that point. So that's what a derivative is. So just to review, if we were in class, I'd split you guys up, have one row find the derivative of 4, another row find the derivative of 3, somebody else find the derivative of 2. So try to just pick one of these and see if you can remember how this worked from yesterday. Maybe pause the video, see if you can figure out what's the derivative at 4, what's the derivative at 3, or what's the derivative at 2. And then I'll just do one of them real quick. So if I found the derivative at 4, that would be, remember, f of 4. Oh, this should have been x plus h, I guess. I don't know why I put x minus h, but f of 4 plus h, then minus f of 4 over h. And then try not to forget that you're always trying to figure out what happens as h gets close to 0. So if I take this and I'm trying to figure out what this function does, what's the slope when x is 4, plug in 4 for the x's, and then I got to just evaluate this using the function. Or again, there's that other method where it's basically the same thing. You could think of what's the point at 4, so you could plug in 4 and get a y value, and then plug in 4 plus h and get a y value. And then if you just do the slope between these 2 points, you'll get the same thing as if you do this. So it's up to you which way you want to think about it. So if I plug in 4 squared plus 3, that's 16, plus 3, that's 19. So we really have the point 4, 19. So f of 4 will be 19. And then 4 plus h, you'd have to plug in 4 plus h squared plus 3. So you could do that over here, just do it over here, it doesn't matter. So f of 4 plus h, that'll be 4 plus h squared, because whatever's in the parentheses, you're just plugging in for x. So 4 plus h squared, and just don't forget the plus 3. A lot of times people forget that. Then it's minus f of 4. I already did that, but if I plug in 4, 16 plus 3 is 19, so it'll be minus 19. So that's f of 4 plus h right there, minus f of 4 right there over h. And then you just have to take the time to distribute this. Don't just think it's 16 plus h squared. It's not quite that simple because you'll get that middle term. So write it off to the side if you need to, 4 plus h times 4 plus h. But I'll just do it real quick. You get 16 plus 8h plus h squared. And then you have plus 3 minus 19. So that's really just minus 16 if you want to simplify that. And then, again, this happens a lot with derivatives. You'll see this 16 minus 16 will cancel out. Then you can probably already see what's going to happen with this h, since these both have h, if you can look ahead quickly. But if not, just take your time. You got 8h plus h squared over h. Now you can either break this into two fractions, put 8h over h and h squared over h, and simplify them separately. Or you can just factor out an h on the top, since there's the h that it'll cancel with on the bottom. So if you factor out an h from 8h, it'll just be 8. And then factor out an h from h squared, it'll be an h. And then the h over h is just 1, so it reduces. So we got down to 8 plus h. And then remember, we're always trying to figure out what happens as h becomes 0 for these derivatives. So if you plug in a 0 for h right here, that's just going to turn into 8. So what that tells us is this curve has a slope of 8 when x is 4. So when x is 4, you could say something like this. You could say like the derivative when x is 4 is 8. So what that would say is the slope of this function when we plug in 4 is 8. So that's going to have a slope of 8. So you could try the same thing with 3. You could try the same thing with 2. You could do all this work with 3 plus h and 3 and 2 plus h and 2. If you want to try it, go ahead. I'll just tell you what the answers would be. The derivative when x is 3 would be 6. The derivative when x is 2 would be 4. So if you want to try either of those, see if you can figure out how to get 6 when you do 3 plus h and 3, or 4 when you do 2 plus h and 2. It'd be worth practicing if you didn't quite get this one all on your own. So again, what you're going to do in calculus, though, is quite often you're not going to find just a slope at one point. You're going to want to find the derivative function or the derivative equation of this, so that you can find the slope at any point you need, or find other characteristics that you'll study. So this is what you'll do most of the time with a derivative in a calculus class. So see if you can follow where this comes from. It says, see if you can use the derivative formula, just like we did up here, to come up with a derivative function so that we can quickly determine the slope of the curve at any given point that we choose. So when you do this up here, instead of like plugging in 4 to find the slope when x is 4, you're just going to keep the x as an x and find the derivative. Therefore, when you're done, you can just plug in whatever number you want for x at the end. So you're going to do all of this work that we did here, but instead of this being a 4 and this being a 4, you're just going to keep it as an x and an x, and then you're going to do all this work, and you'll get something with an x in it at the end, and that'll be your derivative function, which then you'll be able to plug in whatever x you want at the end, and you can just quickly get the answer without having to do all this work again each time. So see if you can see how it's going to work. You're going to keep the x as an x here and do a bunch of work. It's going to have a bunch of variables in it. It's going to look pretty complicated at first, but it will simplify similarly to this. So again, just remember the derivative formula is this. I'll try to help you set it up, because it's the first time you've seen anything like this, and see if you can start to see what it might look like, and then see if you can finish it from there. So that's the derivative formula. Our function that we're dealing with is going to be the same one, x squared plus 3. So what we want to do is just do this, but it's not going to be 4 plus h and 4. We're just going to keep it as x plus h and x. So it's going to look a little different at first, but it's the same idea. So when it was 4 plus h, we plugged in 4 plus h for the x, and we wrote 4 plus h squared plus 3. So when it's x plus h, we're just going to do the same thing. We're just going to plug in x plus h right here. So this is going to be x plus h squared plus 3. So that's the f of x part right here, is this part right here. So that's the f of x part. And then we have the minus, and then we have the f of x part. So this f of x part's going to go here. So we did f of x plus h, that's that, minus f of x means just plug in x, or f of x is just f of x. So if I plug in x, I'm still going to get x squared plus 3. So this is going to be x squared plus 3. But just don't forget, since it's minus right here, we pretty much have to think of this as being in parentheses. So we have to distribute the negative when we go to that. So we have f of x plus h, which is just this function with x plus h plugged in. and then minus f of x, which just keeps the function the same. And then don't forget it's always over h. So this is the first one of these you've seen. We're going to practice these a lot in the next week's videos. So try to just see if you can follow this one today, and then we'll practice some more of them throughout the next couple lessons. So that's f of x plus h. That's f of x over h. Now the hardest part is just distributing this, and then the rest of it's going to be pretty simple. So x plus h squared, it's not just x squared plus h squared. Make sure you get out of that habit if you ever had that as a habit. But x plus h times x plus h, that's what x plus h squared is. So I'll just do this off to the side just so you can see it, because it's a little more complicated. So x times x is x squared. X times h is just xh. Then h times x, that's the same thing as x times h, so you're going to say xh or hx, whatever. And then h times h is h squared. So these two, since they're the same, there's like one of them here and one of them here, so it would add up to 2. So this would be x squared plus 2xh plus h squared. So that's what this part is, so I'll just start with that down here. I'll have x squared plus 2xh plus h squared. So that's what we got from right here, is what this is. And then the plus 3, I'll just put a plus 3 next to this. And then I have minus x squared, and then minus 3 when I distribute this minus. I have minus x squared and minus 3, and then it's always over h. And then just like with all derivatives, a lot of this stuff will cancel out. You see a positive 3 and a minus 3 in the same set of terms. That's going to cancel out. Positive x squared minus x squared, that's going to cancel out. So we have 2xh plus h squared left on the top over h. So we have 2xh plus h squared over h. And then again, this is where you could write this as two fractions, write this over h plus h squared over h and reduce them. Or you just factor out an h on the top and reduce it. You'll get the same answer either way. So if I factor out an h on the top and keep it over h, if I factor out h from this, I'll still have 2x. If I factor out h from this, I'll still have h. And then this h over this h cancels out. So now I have 2x plus h. And remember, we're always trying to make the h become 0. So if I just think about bringing this down here, just, you don't have to draw this arrow, but just so you see where that comes from. If I make that a 0, 2x plus 0 is just 2x. So this derivative is just 2x. So what they would say is the derivative of f of x equals x squared plus 3 is the function. Again, the derivative, they just use this little prime symbol. F prime of x is 2x. So if you have a function x squared plus 3, its derivative function is 2x. So again, this is the long way to do it. If you ask any calculus student what's the derivative of this, they'll be able to tell you it's 2x within like a second. It's really easy once you learn the shortcut. I'll show you that in a minute. But this is just the long way to find a derivative, the kind of the foundational way of where a derivative was defined, how they figured it out in the first place, was using this process here. But again, we'll learn a shortcut pretty quickly. So that's the derivative of this. Now just to show you how that works, look at how simply we could have used this to find all these answers up here. Because I said to find the slope when x is 4, we did all this work, and we figured out the slope is 8. This derivative just tells us the derivative or the slope of this function at any x value is just 2x. So if I want to know the slope when x is 4, look how simple that was. All I would have to do is 2 times 4 and get 8. So again, calculus isn't really hard all the time. A lot of it's really simple. Just learning a lot of the reasoning behind it. And there's hard stuff you'll do, but derivatives in their simplest form aren't really that hard. So 2x, if I wanted to find the slope when x is 3, look how simple that is. 2 times 3, the slope would be 6 when x is 3. If I want to know the slope of this curve when x is 2, just plug in 2 to the derivative. 2 times 2 is 4. That tells me the slope of this curve would have been 4 when x is 2. So that's what a derivative can be used for. This function will tell you the slope of this function at any point. So that's a long way to find derivatives. We'll practice a few of those. Again, by the end of the calculus class, you probably won't even remember this very well because you won't do it too much towards the end because you'll just learn a bunch of shortcuts. So there's kind of 4 or 5 main shortcuts for derivatives in calculus. I'm only going to show you guys one in these videos. If anybody wants to start learning some of the other ones, there's 2 more that are really useful. If anybody's just curious, like if this one makes sense and you get kind of interested in it, you want me to show you the other 2, just email me or just come on Zoom anytime. I can show you something called the product rule or the quote or the chain rule, which is a really interesting one that's kind of tough to learn, but I could show you and you can get a good head start on it. This one's really easy. It's a shortcut for finding the derivatives of polynomial functions. So polynomial functions, just simple ones like x squared plus 3. We did all the long way and we figured out the derivative is 2x. So keep this one in mind, because in a second I'm going to show you the shortcut. Like a minute ago I just told you, like a calculus student, if you asked them for the derivative of this, they could tell you it's 2x within a second or two, because it's really quick. So keep that in mind, because in the next few minutes you'll probably be able to figure this out just as easily, why that's 2x. So there's something, this is kind of the one you'll use the most in a calculus class. You'll use it every day pretty much, many times a day usually. It's called the power rule, and it's a really easy way to find a derivative of just if they have x to various powers in your function. So if it's a little more complicated, it's not quite this simple, but if it's just a bunch of terms with x to different powers, derivatives of these are really easy. So I'm just going to show you the first couple, see if you can start to just think what I might be doing. So I'm going to take, the way to do it is you do it kind of term by term. So I'm going to show you what the derivative of these first couple would be, and then see if you can maybe take a guess what you think the derivatives of a couple of these are after you see it. So it's one of these things, it's pretty easy. Once you learn it, you'll probably not really ever forget it. So even if you never take calculus for a few years, you'll probably remember this after that, because it's something that's just, you use a lot, it gets pretty simple to do. So the derivative of x to the fourth, I'll just start with that. That's going to be 4x to the third. So do a few of these, see if you can start to see a pattern in maybe what I'm doing. The derivative of 2x to the third, that's 6x squared. The derivative of negative 5x squared, that's negative 10x to the first, or negative 10x. These are getting a little tricky. The derivative of 4x is just 4, or you could say it's 4x to the 0 power. And the derivative of negative 2 is just 0. So you don't write the derivative of negative 2, it's just 0. So that's the derivative of that function. Did it again term by term. I'll do one more, see if you can start to see maybe what I'm doing here. See if you can maybe even figure out what the derivative of 7x to the sixth would be all on your own. So 3x to the third, that would have a derivative of 9x squared. X squared would have a derivative of 2x, or 2x to the first power. And then 7x would have a derivative of 7, or 7x to the 0 power, you could say. So take a look at that, see where you think maybe the 9 and the 2 came from, where the powers come from. Think about why that became negative 10, that became 6, that became 4. So again, see if you can figure out maybe what you think the derivative of 7x to the sixth would be. So 7x to the sixth is going to be 42x to the fifth power. And the derivative of 8 is just going to be 0. So we don't usually put that. You could put plus 0 if you want. So if you haven't seen it yet, hopefully this one kind of gives it away. Think about where the 42 could have come from, where the 5 could have come from. So if you didn't guess that one correctly, maybe you're kind of seeing it now. If you're still totally confused even after that one, I'll show it in a second how to get these, but see if you can keep trying to guess these if you're kind of getting the hang of it. So this one would be negative 15x to the fourth would be the derivative of that. So the derivative of 2x squared is going to be 4x to the first, or just 4x. And the derivative of negative 2 would just be 0. So again, hopefully you're kind of seeing some of these. If not, maybe rewind it, take a look back at those again, see if you can start to see, like, look where the 42 could have come from, or where this negative 15 could have come from, or where this number 9 could have come from, or the number 6 right there on 2x to the third, and see what's happening with the powers. So x to the sixth, again, you can take a guess on that. That'd be 6x to the fifth, and then 2x to the fourth, that would be 8x to the third. And then negative 3x squared, that'd be negative 6x to the first. So again, if you got the hang of it, see if you can try this last one here on your own real quick. And then that would be 24x to the third. And negative 2 is not going to have a derivative. That's going to be 0, so we don't put that. Now, if you kind of got the hang of these, again, if you're not sure still how I did those, I'll explain it in a second. But if you kind of got the hang of these are a little bit more advanced ones that, again, they'll be easy when you're in a calculus class. But if you've been following a lot of the videos the last few weeks, you may have heard me say a few times, like, And even back in class, when we were still in class, I might have said this a few times, that in calculus, when you see square root of x, you'll never write it as square root of x most of the time. You'll always want to write this as a power of x. So remember, square root, that can be changed into a fraction power. And remember, the fractions, it's the power over the root. So this is x to the first power, and the square root is like the second root. So the square root of x is really just x to the 1/2 power. So now you can use the pattern you saw up here if you figured it out. If you still haven't figured it out, I'll explain it in a second. But use the pattern you used up here. You can probably figure out what the derivative of that would be. So see if you can figure out what the derivative of that one would be. So if you do what you did up here, you'd put the 1/2 in the front times x, and then the power is going to have to be the negative 1/2 power, like that. So that would be the derivative of square root of x would be something like that. There's a couple different forms you could write that answer in, but that's the answer there. So see if you can do something similar on this one. I've mentioned it before that in calculus, you usually don't want to write x on the bottom. And this is one of the reasons why. Finding derivatives is a lot easier if the x is a power, if the x is on top. So see if you can think how else you could write 4 over x. So this is like 4 over x to the 1. So if you move that x to the 1 to the top, it would just turn negative. So this is like 4x to the negative 1. Because if you have x to the negative 1, you can put it to the bottom, that would be positive x. So 4 over x is the same as 4x to the negative 1. So now see if you can figure out the derivative of 4 over x. So what's the derivative of this? So see if you can follow that pattern you used up there, figure it out. So you'd end up with negative 4x to the negative 2 power. So that's the derivative of 4 over x. So you basically figured out how to find simple derivatives in calculus if you figured out that pattern. So we'll do a little bit of practice with that. But just in case anybody didn't quite figure out the pattern, I'll go over it here quickly. So if you look this up in a textbook, or if you look up online, the power rule for a derivative, you'll probably see something like this. This is basically the symbol, like symbolizing the rule. So see if you can figure out what's the derivative of something in this form, ax to the nth power. So if you figured out 6x to the 4th or negative 3x to the 5th, what is the derivative? What is the pattern for the derivative of ax to the n? So see if you figure it out. See if you can try to write that or type that. What's the derivative of ax to the nth power? So hopefully some of you guys figured this out. What you notice in the pattern maybe is that this power gets multiplied by this number. So this is going to be either n times a or a times n, however you want to write it. So you can put n times a or a times n, however you want. So it's n times a is the coefficient, and then that's times x. And then the power, hopefully what you notice is that the power goes down by 1. So you can say the power is now 1 less than it was before. So that's the power rule right there. So anything times x to a power is going to be the power times the coefficient, and then the power is going to go down by 1. So if you look back at some of these, if you didn't quite figure this out before, that's where I got 4x to the 3rd, because 4 times 1 is 4, and then the power goes down by 1. And then 3 times 2 makes 6, and then the power goes down by 1. 2 times negative 5 makes negative 10, and the power goes down to 1. Now these are where it gets a little more interesting. This is like 4x to the 1. So 1 times 4 is 4, and then x to the 0, you really don't even write x to the 0. So you could put x to the 0 here, but it just doesn't show up. And then if you think about it, this is kind of like x to the 0 here. So 0 times 2 just makes 0. So it'd be like 0x to the negative 1, but that's just 0. So a constant, the derivative is always going to be 0. If it's just 5x or 4x, it's just going to be 4. So like 7x was just 7. But 8, the derivative of 8 is just 0. So the derivative of 7x is 7, because it's like 7x to the 1. The derivative of 8 is just 0, because it's like 8x to the 0. So that's a quick introduction to the power rule. We'll use that on the next couple videos just to practice it a little bit. So if we were in class, this is going to be a little bit of classwork I'd have you do just to kind of practice this and kind of prove some of these things, see if you can figure out, kind of make sense of some of this stuff, because it's a lot to take in at once. But if you start to see it in all the different forms, it's kind of interesting how it all ties together, a lot of things I've been trying to show you. So the derivatives, I'm going to kind of show you kind of everything I've gone over in the last few videos and show that it all works together on one function. So if you have the function x squared plus 4x, it makes this graph. So first thing I would want you to do, if you had this and printed out, you could try it. If not, you could just kind of visualize what you think the derivative should look like and see if it matches what I draw. So we practiced this a little bit trying to draw the graph of a derivative, which is pretty tough. It's not the most important skill for calculus, but it's good if you can figure it out. So remember, when you draw a derivative, you can start anywhere, but I always like to start where the graph flattens out or turns around. That's where the slope is 0. So right there, the slope is 0. So on the derivative, this graph should be at 0 right there. Then you can just kind of estimate, like right in here, looks like the slope's about 1. This slope's about 1. In between here and here, looks like the slope's about like 3 right there. So slope's about 1 right there, about 3 right there. Looks like slope's even about like 5 somewhere in here. It goes up like up 5 over 1. So the slope is changing. Every single point along here has a different slope. But just in the middle of this area, it's probably about 1. Somewhere in this area, it's about 3. Somewhere in that area, it gets up to about 5. So I'd probably put a point around 1 right in here, around 3 maybe right in here, around 5 maybe right in here. So that's what the derivative would look like, something like that. On this side, this is like a -1 slope. This right here is about a -3 slope in here. If you go look between like here and here, you might say it's about -4 or -5 slope somewhere in there. So I'd say the graph somewhere around -1 here, somewhere around -3 down here, somewhere around -5 and around in this area on the x. So the derivative probably looks something like that. Now, it says determine the derivative using the power rule we just studied. So see if you can use what we just talked about. If that's the function, what's the derivative of this function? So take each term at a time, do the power rule. So you bring down the power and multiply it, and then take the power down by 1. So if this is 1x squared, you do 2 times 1, and then take the power down by 1. So it'd be 2x to the first, or 2x. And then 4x is 4x to the first. So if I bring that power down, 1 times 4 is 4, and then the power goes down to 0. So it's 4x to the 0, or just 4. So 2x plus 4 is the actual derivative. So my drawing's just an estimate. It should be, somewhat of the same shape, but it doesn't need to be that exact. But 2x plus 4, if you look at it, 2x plus 4 would add a y-intercept of 4. So my graph was off a little bit. Again, it's just an estimate. And the slope is 2, so it should be going up 2 over 1. So the exact derivative would have been this one, 2x plus 4. So again, my sketch was pretty close. Again, the sketches don't even have to be that close, but it should. This point's really important. Both of them should have that point right, because that's where the slope is 0. But again, my estimates were a little off. If your estimates were way off, like if you drew like this as the derivative, that would still be pretty good. That would still be acceptable as a sketch. But 2x plus 4 is the exact derivative. So you can see how sketching the graph kind of matches up with this. The last thing I want to do is show you how to do it the long way. So this was the shortcut way, but let's see if we can find the derivative of this the long way one more time, see if we can practice that. There's the last one you have to do the long way today on these, but then we'll practice some more later. But see if you can do the derivative formula with this and see if you can get 2x plus 4. So if you want to pause it, see if you can do it on your own. This would be a really good challenge. If you could do this all on your own, you got to plug in x plus h twice. That's what makes it a little harder than the one we did before. But see if you can figure this one out. If you can get it all the way down to 2x plus 4, that'd be awesome work at this point. If you get a little stuck, I would totally expect that. You might want to just pause it and then maybe play through the video, maybe see if you can work through it while I do, and pause it as you get to some next steps. Maybe you want to try, you can pause it again and just try to work ahead. So f of x plus h minus f of x. The first part is plug in x plus h to the function for both x's. So you'll get x squared will turn into x plus h squared. So that's the x squared, and then the 4x will turn into plus 4 times x plus h. So the first step is always plug in x plus h wherever there's an x and just rewrite the function like that. And then you do this minus sign. So you got a big minus, and then f of x. So after the minus, you always want to put that in parentheses, whatever you put after the minus. F of x basically means just rewrite the function again, or plug in x, which just doesn't change it. So if I plug in x, I'll get x squared plus 4x, basically. So that's the minus f of x part. So this is f of x plus h minus f of x, and then it's always over h. Now, all you really got to do is take your time, distribute this, and the rest of it should be pretty simple, the simplifying. But the distributing, just take your time. I already did x plus h squared on the other page, so I'm just going to write what I know that is. That's x squared plus 2xh plus h squared. So that's what this will be if you distribute that. And then all you have to do is distribute a 4 to these. That's pretty easy. It'd be plus 4x plus 4h. And then you have to distribute the negative to these. So it'd be minus x squared and minus 4x. That's really the hard work from there. So if you want to pause this again, see if you can simplify this down. See if you can get it down to 2x plus 4. And remember, you're going to plug in 0 for h at the end. But this is the hardest step. Most people have a lot of trouble figuring out how to write this. So if you're still confused how to write that, maybe go back to when I was explaining that. See if you can figure out where all this came from. But then from here, it's usually pretty simple. A lot of terms will cancel out, like x squared minus x squared, 4x minus 4x cancels out. Then just try not to lose any of these terms. So you have 2xh plus h squared plus this 4h. And then it's all over h. And then notice they all have an h in them, and there's an h on the bottom, so you can factor out an h on the top and cancel it with the h on the bottom. If I factor out an h, I'll have 2x plus h plus 4. And then these h's cancel out. And then remember, we're trying to make the h become 0, so if this h just becomes 0 right here, that's 2x plus 4, which is what we knew the derivative was from the shortcut. But that just shows you that the shortcut works, but so does the derivative formula. So you get the derivative as 2x plus 4. So that problem right there kind of ties together everything we've done the last few videos. Yeah, that's pretty advanced stuff. That's something that might take a few weeks to get through in calculus. So if you already understand that before you even start a calculus class, you'll be quite a bit ahead. But not to say it's going to be easy after that. There's still a lot of difficult stuff you got to study. But if you can understand that, you'll be in pretty good shape to start calculus. Even if you don't know that, the teacher won't expect you to know that. So it's good if you do. So on the back of this, there's a couple problems. I'm not going to go through all this because this is getting long already. But on the back, there's a couple problems I just want to show you quickly, and then you can try some more of these on the other page I gave you. So it says, find the derivative of each function below. So that's just practicing the power rule. So I'm not going to do all these, but see if you can maybe figure out the derivative of that one. So this one, you'll multiply 3 times 4, get 12. And then the power will go down by 1, so go down to 12x squared. This one you'll do 2 times negative 5, so you get negative 10. And then the power will go down by 1, so it's x to the first. And then this is 4x to the 1, so you do 1 times 4. And then the power goes down to 0. So x to the 0, we don't even write x to the 0, because that's just 1. So that's like 4 times 1, or 4. So that'd be that one. So if you want to try these, go ahead. I'll just put this one up real quick. It'd be 4x to the third plus 3, and then remember, if there's no x, the derivative is just going to be 0, so you don't do anything for the minus 7. So that's that. What's more important, though, is a little bit more advanced problem like this. So make sure you can do that, and you'll use it on a problem like this. So if it says, what you really want to remember about a derivative is that it tells you what the slope of the original graph is. So if somebody asked you, what is the slope of this curve when x is 2? You could graph this on Desmos and kind of estimate what you think the slope is. But if you want to know the exact slope, that's when you use the derivative. So make sure you see how to use this. If you want to know the slope of this, first thing is find the derivative, because the derivative is basically a function that tells you the slope of this graph. That's all a derivative is. So first find the derivative of this one. So you'd get 12, well, I guess it's the same one we just had up here. You get 12x squared minus 10x plus 4. Now the question is, you want to know what's the slope of this graph when x is 2. So think about what you do to find that. You want to know the slope of this graph when x is 2. So you're not trying to figure out where is this graph or what's the y value of this graph when x is 2. If that was the case, you'd plug in 2 right here. If you want to know the slope of this graph, that's what the derivative is used for. So you'd plug in 2 to the derivative to find the slope of this graph. That's what a derivative is. So if you can understand that, again, before you start a calculus class, you'd be way ahead if you just knew the derivative function is a function that tells you the slope of the original function. So I would do, what's the derivative of 2? So I would do 12 times 2 squared minus 10 times 2 plus 4. So that'd be 4 times 12, that's 48, minus 20 plus 4. So I'm doing this quickly. If I make a mistake, excuse me, but you can figure out the answer, I'm sure. But this would be, what, 28 plus 4. So again, if I did that right, I think it's 32. So that would mean the slope of this graph is 32 when x is 2. So we use the derivative to find the slope. So 5 and 6, I wouldn't even worry about those. I haven't even talked much about that, but maybe some of that will make sense. 7 and 8, if you want to practice sketching those graphs, you can. And then there's another page of problems just to practice a few like this and practice a few like this. I would really recommend it, especially if you want to take calculus next year. If you're kind of getting the hang of this and you just think it's interesting, you want to try those, I would really recommend trying that next page for the assignment also. So hopefully you learned a little bit about derivatives. Next week, we'll just keep practicing this, just kind of keep solidifying this. We're not going to go into too much more new stuff, just kind of keep getting you better at understanding what a derivative is and how to find it. And again, if you like this power rule thing, or you're just curious what the other shortcuts are, there's 2 or 3 other main shortcuts you'll use a lot in calculus. I could show you those if anybody's curious, just wants to kind of get a little bit ahead. Just email me or come on the Zoom. I can show you those anytime.